The third problem, E3, two masses over a pulley. So here there's a pulley, and we're hanging a mass on one side and a mass going to hang on the other side. So you have M2 and you have M1. This is straight down, just hanging. So that's our sketch, and you're asked to find the acceleration and the tension T in the rope. So we have two force diagrams. So here's our sketch, and then here's our force diagrams. Going to be two of them. We have to pick a sign direction. I'm going to pick this way as plus, and if I find out the answer comes out negative, just means it's going the other way. All right, so this one here is going to have, you can just see it here, T going up, you know, M1G going down. So let's go ahead and do the free body diagram where it's here. So you have T, M1G. Then over here, you know, T goes up and you have M2G. I probably wouldn't do that in a homework problem. I would just do it over here. Don't want to clutter that up. So M2G, and there's T going up. And then for 3, the equations, T goes up, because the up is positive in our convention that goes along with positive here. So up is positive for M1 and then positive for M2 going down. So this is T minus M1G equals MA, and that's the mass 1. And then over here we have M2G minus T is M2A. So then we solve, and for solving, we add the equations, take advantage of the action-reaction, and then when you do that, you'll have minus M1G plus M2G equals M1A plus M2A, and we're almost finished. Here we're finding M2 minus M1 can be factored with the G factored out like this, and here M1 plus M2 can come out, you know, bring the A out rather. And then you have your answer that the acceleration is M2 minus M1 over M1 plus M2 G. So that's the acceleration. Okay, so for the tension, I'm going to use this first equation here. T is M1G plus M1A. And we could use the A, that equation. So T is M1 G plus M1 M2 minus M1 over the sum times G. Now I can pull out, here I can pull out an M1G out of everything. So let me go ahead and do that. Here's an M1, and I'll have 1 plus M2 minus M1 over M1 plus M2, and I'll put the G on the far right. So I have M1G, and then I have M1 times all this mass stuff times G. This we can add together by finding common denominator, N1 plus M2 plus M2 minus M1. So here, this grouping, when you divide the sum into the sum, you get 1, and then this is the second term. Notice that these cancel. And for the tension, you get M1, there's 2 here, M2 over the sum times g. Notice that the dimensions check out. This is an acceleration since the ratio is dimensionless, and here with the extra m factor, you have an mg kind of thing. So we can check here if take the limit, check one, let's say m1 is very, very large compared to m2. Then you're going to have negative acceleration. M1's going to fall freely. It's going to be negative g, the way I set up that plus. So if I take the limit as m1 goes to infinity of m2 minus m1 over m1 plus m2, I go ahead and prepare by dividing top and bottom by m1. And we have this. And when m1 goes to infinity, gets 0. This is 0 minus 1, 1 plus 0. You get, and there's a g in there. You get minus g, which is what we expected. And what happens, the tension, let's go with the tension. So the tension here is you take the limit as m1 goes to infinity of the tension 2m1 over m2, m1 plus m2, like this. We get the limit as m1 goes to infinity 2m2 over 1 plus m2 over m1, and you wind up with 2 m2g. Hey, does that make sense? Well, if m1 is very, very large, this is saying that the tension in the rope is 2m2g. Well, let's think about this. Suppose that you were balanced and the m's were the same. Then the tension would be just m2g, and m2 would be m1. But now if you accelerate this going upward, an acceleration g, you're going to pick up another m2g. So it's going to be 2m2g. That checks out. And then we do check 2. If the m2 is greater than the m1, will the reverse occur? Well, let's see. If m2 goes to infinity, m2 minus m1 over m1 plus m2, the limit as m2 goes to infinity. So now we're going to divide by m2, 1 minus m1 over m2, m1 over m2 plus 1 with the g. This is going to 0, 0, so you're going to get g. So it's going to be going to the right, down. And let's check the tension. The tension is 2m1, m2 over m1 plus m2, g. Preparing this one, we have 2m1 over m1 over m2 plus 1, and you get 2m1g, and that's what you expect. Minus g becomes plus g since we're going the other way, in other words, in the plus direction. And the 2m1g is analogous to the 2m2g we had before.